exponential and logarithmic equations. All right, and so the main thing we're going to try to do is always get our exponential or logarithmic equation. We're going to use the properties of exponents and logarithms to rewrite the equation to one of three forms. If we can use logarithms or we can just rewrite it into exponential form and solve, then we're going to do that as well. So the first form we want to try to get into it is what we saw in our first video. B to the x equals b to the y. So if things have a common base, a common power, rewrite it into that common base. And then if that is true, then we know that in this case, just x equals y, and we can solve that equation. If we have log base b of x equals a, so if we can get our equation to look like this, right, where b and a are some numbers, the reason we want to do this is because b to the a, which would be a number, is just equal to my x value. All right, and so again, b to the a would be some number if b and a are numbers here, and then we can just solve for x. The other way is if we can get a log base b of x equal to a log base b of y. This is similar to 1, but for logarithms now, because then again, x just equals y. So let's go through some examples of this. So example 1 here, solve 10 to the x plus 1 equals 150. So to use 1 up here, we would need to find a common base. 150 is not a common power of 10, right? 10 to no whole number will give you 150. So what we're going to do is we're going to rewrite this using logarithms. And we're going to use the property that log of 10 to the b equals b. So what we're going to do is we're going to take log base 10 of both sides. So log 10 to the x plus 1 is equal to log 150. So I'm taking the log of both sides. Right? Now, log base 10 of x plus 1 to the x plus 1 is just x plus 1 because log of 10 is 1. Right? So we're going to move that to the front. And that leaves you with log base 10 of 10, which is 1. So x plus 1 equals log of 150. And so to solve for x, I just subtract 1 from both sides. So minus 1 plus log 150. And that is my answer for x. For number 2, log of x squared equals 2. So this looks like number 2 form, right? Log base b of x equals a. So you have to remember here that log of x squared, so log base 10 of x squared equals 2. So this means that 10 to the second power equals x squared. So 100 equals x squared. And if I solve by taking the square root of both sides, you get x equals plus or minus 10. And so if we plug in 10 here, you get log of 100. That's going to be 2. If you plug in negative 10, you get negative 10 squared, which is also 100. And so we get the same results. Number 3, we have natural log of 3x minus 2 plus natural log of x minus 1 equals 2 natural log of x. And so I want to get this one into form number 3. I'm going to rewrite this as natural log. This is a sum of 2 logarithms, and so this becomes a product. And over here, I need to move this to the exponent. So this becomes natural log of x squared. Now that I have a single log on the left-hand side and a single log on the right-hand side, the arguments must then be equal, right? Log base b of x equals log base b of y, then x equals y. So I'm going to have 3x squared, or 3x minus 2, x minus 1 equals x squared. And now I need to solve this. So I'm going to FOIL this out. 3x squared minus 5x plus 2 equals x squared. It's a quadratic, so I need to set it equal to 0. So 2x squared minus 5x plus 2 equals 0. I'm going to factor this. So 4x squared, negative 5x. So two numbers that multiply to 4 and add to negative 5. That's negative x and negative 4x. So I'm going to get 2x squared minus x minus 4x plus 2 equals 0. I'm going to factor by grouping now. I'm going to get x, 2x minus 1, minus 2, 2x minus 1 equals 0. And now I can factor out my 2x minus 1. So my two solutions are x equals 1/2 and x equals 2. And now we need to check answers. So if I plug in a 1/2, I'm going to get 1.5 minus 2. That is a negative number, and we cannot have a negative inside a logarithm. Therefore, 1/2 is not in my solution set. It is an extraneous solution. If I plug in a 2, I'm going to get natural log of 4 plus the natural log of 3. Right? 6 minus 2 is 4. I'm sorry, I'm going to get the natural log of 1 here. 2 minus 1 is 1. And over here, I'm going to have 2 natural log of 2, which is the natural log of 4. And so 2 is my only solution here. So it's really important that you check your answers for extraneous solutions. Number 4, solve log base x minus 2 minus log of x plus 4 equals log of x minus 3 minus log of x plus 1. So once again, I'm going to use number 3 here. I'm going to get to 1 log on each side. There's a subtraction, so this means I'm going to use the quotient rule. On this side, I'm going to have x minus 3, x plus 1. Once I have 1 log on each side, I know my arguments must be equal to each other. To solve this, you have to cross multiply. And now I'm going to have to FOIL. And now I'm going to solve for x. Now notice it is a quadratic to start, but my x squareds will cancel. And if I bring negative 12 to this side, I'm going to get a 10 equals 2x. And so x equals 5. Now I need to check, does 5 make any of my arguments negative? This would be a 3. This would be 9, 2, 6. My check's complete. My solution is x equals 5. All right, so these are some examples of solving. On the next page are some problems for you to try. The next video will have the solutions to that.